So just prepare for one of the five, whatever you like. Okay. So I'm just listing out here the 10 principles. So first one is take an economic view, then the apply system thinkings, assume variability and preserves options, build incrementally with fast integrated learning cycles, base milestones on objective evaluation of working systems, make value flow without interruptions, apply cadence, synchronize with cross domain planning, unlock the intrinsic motivation of knowledge workers, decentralize decision making, and the organize around value. So these are some 10 principles. Just make prepare for one of the five principles and elaborate more. Okay, so let's go ahead and see what is agile economics delivery early and often. In the waterfall model, you can see we have to do the requirement gathering first, then the design with the documentation, and then implementation with unverified system, and then we can do the verification. After verification and testing, we can release that product. Okay, it's almost around 3 to 5 years of projects. Okay, yeah. So in the increment delivery, that is in agile, we are doing the same things for in the smaller pieces of the features, and we are releasing that, okay, with the incremental basis. So this is the difference in between those two. Okay, let's go ahead and see the next topic is the system thinking. So attributes of system thinking is optimizing the components does not optimize the system. Okay, so we need to optimize the component for the system to behave well as a system. A higher level understanding of behavior and the architecture is required. So that's why we are having the architect person in that. Okay, then the value of the system passes through the interconnections of the, okay, this is the solutions, that is enterprise building. The solution is a system too. Okay, a system can evolve no faster than its slower integration points. Okay, so this is all about the system thinking of the agile. So then the next topic is related to development occur in uncertain world. What exactly it is? Rather than try to pick an early winner, aggressively eliminate alternatives through analysis, simulation, and the testing. You cannot possibly know everything at the start. It's of course okay. Requirement must be flexible to make economic design choices. You know, the competition is there, so always the world is changing continuously. So that's why it should be flexible. Okay, so design must be flexible to support changing requirements. Whatever client or the customers are required as per the market, so market is changing, so that's why our design also supporting some changes requirement. Okay, so preservation of the option improves economic results. So you can see the it's a cone of uncertainty. Okay, yeah, so set based design facilitates learning and allows for continuous cost effective adjustments towards an optimal solution. This is the pro tip. Okay, this is set based design, we need it. Okay, the next is apply fast learning cycles. This is the PDCA. What exactly it is? Plan, do, check, and adjust. Again, plan, do, check, and adjust. Okay, this is the iterative learning cycles. So fast feedback accelerates the knowledge, so we need the fast feedback loop. So, improve learning efficiency by decreasing the time between the action and effect, reduce the cost of risk taking by truncating unnecessary path quickly, is facilitated by small batch size. Okay, small batches requires increased investment in development environment. The shorter the cycle, the faster the learnings. Okay, so that we can get the feedback and we can do plan, do check, and again adjust things. Okay, yeah. So in the integration points control product development, we can say it's a product development is the creation of the reusable knowledge through set-based design and establishment of the development cadence and flow. So integration points accelerate the learnings. Development can proceed no faster than the slowest learning loop, that is feedback loop. Improvement can through the synchronization of the design loops and faster learning cycles. So the next topic is apply objective milestones. PI system, that is system demos, means what? Product increments. Okay, system demos are orchestrated to deliver objective progress, product, and process metrics. These are three P, that is progress, product, and process metrics. Okay, you can see it's in the graph how it is working. Objectives are in the progress, then the product is feedback and product solution performance and those things, and the process are improvement backlog items. This is the PI system demo. You can see it's a picture of it. Okay, yeah, this is the product increment. Fine, yeah. So there are some 8 flow accelerators. What those are? Flow 8 flow accelerators, that is visualize and limit the WIP, that is work in progress. Address bottlenecks, minimize the handoffs and dependencies. Okay, get faster feedback loop. Work in smaller batches. Reduce queue length. Optimize time in zone. Okay, remediate legacy practices and the policies. So these are 8 flow accelerators. If we are keeping these 8 flows are in mind and we are doing in the practice, then we are getting done the increments quickly. Okay, yeah, in smaller chunks. Okay, yeah. So next topic is the importance of the small batches. Why we need the small batches? Large batch sizes increase the variability. High utilization increase the variability. Sever the project shape page is the most likely use result. Okay, small batches go through the faster system with the lower variability. The most important batch is the handoff batch. Okay, if it's smaller, then of course dependency also will get not there. Okay, so finding the optimal batch size is we can see it's a item cost per batch versus cost. Okay, it's a holding cost, transaction cost, with the total cost we need to optimal the batch size, lowest total cost. Okay, how the optimal batch size is an example of a U curve utilization. You can see in the graph it's a U curve. Total cost are the sum of holding cost and the transaction cost. Okay, this is the total. Higher transaction cost make optimal batch size bigger. Higher holding cost make optimal batch size smaller. Okay, we need the batch size smaller. Correct? Yeah. So just concentrate on that. Then the reducing the optimal batch size. How we can do it? Reducing the transaction cost, reduce the total cost and lower optimal batch size. Okay, we need to reduce the transaction cost. Reducing batch size means increase the predictability, accelerates feedback, reduce rework, okay, and lower the cost. That's why we can reduce the batch size. Batch size reduction probability saves twice what you would think about it. Okay, just think about it. Then they reduce the queue length. This is the formula we have given here. This is a very important formula. Just go through it once. Okay, yeah, you can Google it out also. Understand little law, that is faster processing, time decreases wait. Shorter queue lengths decrease wait. Okay, are you getting my point? Faster processing time decrease the wait. Shorter queue lengths decrease the wait. Okay, that's why we need to do the shorter batch releases. Control wait time by controlling queue length. WIP limits, small batches, defer the commitments. We can control the wait limits with that. Okay, this is the wait queue equal to, that is the length queue and the, that is length of queue and the divide by average processing time. Okay, yeah. Example also it's given, like given an average processing speed of 10 features per quarter and a committed set of 30 features. Okay, 10 features per quarter. So committed set of 30 features. Okay, so how we can do it? 30 items, that is 30 features we have to deliver, divide by 10 items per quarter. Then 3 equal to how much? 3 quarters we need to deploy it. Okay, 30 items. Correct? This is the formula we. So this is all about we had discussed so far in this video. Okay, this is related to Scale Agile framework. Okay, we will go and meet in the next part, that is part 3, for further details. Okay, let's be touch with me. Okay, thank you.